Watch the complete playlist on the app Pions. Download the app now.
Calculate the electric potential at the center of a square. So let's draw here a square. So our square here is this, let's say. Each side is root 2 meter. So let's write here root 2 meter. This is our A, this is our B, this is here C, this is here D. Having charges, let's go in the same order. 100 microcoulomb. So I'm for the time being, I'm just, okay, let me write only 100 microcoulomb minus 50 microcoulomb, 20 microcoulombs, and is minus 60 microcoulombs. They are placed at ABCD at the four corners. You have to find the potential at the center of the square. Let me remind you again, scalar quantity it is potential. So if it is at O, first thing, we have to find potential at O due to A. So you need the separation OA, OB, OC, and OD. Correct? To find OA, OB, OC, OD, let's start with our basic geometry because it's a square and each side is of root 2 meter. Let's take here, this is our root 2 meter here also. So let's take the triangle BCD. Using Pythagoras theorem, BD square is equals to BC square plus CD square. Now BC is nothing but root 2, so root 2 square, and CD itself is also root 2, so root 2 square. Root 2, here it will give you 2 and here also 2. So this will give you 4. Now BD square is 4, then root will be, BD will be complete 2, 2 meters. Now if BD is 2 meter, it is a square. So for a square, the diagonals must be equal. AC will also be 2 meter. Great. If BD is 2 meter, AC is 2 meter, let's figure out our values of AO. That will be equal to OB, equal to OC, equals to OD. Sir, why they are equal? Square, the diagonals of a square bisect each other. Bisect means they cut in equal parts. And each will be equal to 1 meter. Again repeating, if this gap here is 2 meters, then half of this gap will be 1 meter. So we got the values. Now let me write here the formulas which I will use to figure out the potentials. So potential at O due to A, that will be equals to 1 by 4 pi epsilon naught charge at A upon OA. Very simple. Potential at O due to B, 1 by 4 pi epsilon naught charge at B upon OB. VOC, 1 by 4 pi epsilon naught charge at C upon OC. Finally, charge potential at O due to D will be 1 by 4 pi epsilon naught charge at D upon OD or DO, whatever you want to write. Clear? Great. What should be the net potential? Let's write it on another page. So net potential at O, the center, must be equal to voltage due to O at O due to A, due to B, due to C, due to D. Sir, why you are directly adding them? First thing, again repeating, it's a scalar quantity. We don't find directions for scalar quantity. Scalar quantity doesn't have directions. Second thing, this law is known as superposition principle. According to superposition principle, the net voltage at any point is equal to the sum of individual voltages due to the charges at that point. Clear? So let me remind you once again, all of them, let's write here 1 by 4 pi epsilon naught charge at A upon OA, 1 by 4 pi epsilon naught charge at B OB, 1 by 4 pi epsilon naught QC OC, 1 by 4 pi epsilon naught QD OD. Let's take common things. Pay attention. OA, OB, OC, OD all are equal. Just now we found they are 1 meter. So let's make it as OA, OA, OA. They are all same. So you can write anything. If you are not comfortable with OA, write it OB or OC or OD, doesn't matter. Now what is common here? 1 by 4 pi epsilon naught into OA is common. Let's write it as 1 by OA. What we left with? Charge at A plus charge at B plus charge at C plus charge at D. Correct. Now what is 1 by 4 pi epsilon naught? We already know 9 into 10 to the power 9. What's the value of OA? 1. Charge at A, let's see the question once again. Charge at A is 100, minus 50, 20 and minus 60. So let's go back. 100 minus 50 plus 20 minus 60. Let me repeat again. These are our negative. 100 minus 50, 20 and minus 60. What about sir microcoulombs? So let's all of them have microcoulomb. So let's take that common also and keep it outside 10 to the power minus 6. Let me repeat. Anyways, you will write it as 100 into 10 to the power minus 6, 50 into 10 to the power minus 6, 20 into 10 to the power minus 6, and 60 into 10 to the power minus 6. You can take 10 to the power minus 6 common out and it will go there. But be very careful. Signs for potential and potential energy is very, very important. So let's multiply. 1 by 1 is anyways 1. 10 to the power 9 and that 10 to the power minus 6 outside. That will make it as 9 into 10 to the power 3. And here 100 minus 50. So 50, 50 plus 20. So 70, 70 minus 60. So 10. So our net voltage at the center of the square is 10 to the power 4 volt. 9 into 10 to the power 4 volt.